Hi, welcome to our webinar on emission limits in process industries and how to minimize polluted air waste streams and related costs. My name is Bas de Bogen. I'm responsible for sales and marketing within JOA Air Solutions. We will discuss today how to address these emissions in about 15 to 20 minutes short and powerful webinar. Structure will be that we first, why is it important, what are the challenge related, how to address these both from the approach and from technical solutions, and I'll end today to give you some case studies on how do we address them in practice in both food industry and chemical industry. So yes, and let me share the presentation. Why is it important? Well, of course, your internal motivation of the company based on the Sustainable Development Goals created by UN, which also relates to the company-specific, often 2030 goals on where to stand, both from an emission point of view, CO2 point of view, volatile organic compound point of view, and last but not least, costs related to those emissions. Externally, of course, is to comply, make sure your license to operate isn't in play, and public opinion. In the last couple of years, we see a rising interest of the public audience on Fortune 500 companies. What are they? How do they addressing their emission control? And how do they communicate about it? So, what are the challenges? First, changing and more stringent legislation. As I mentioned before, rising public pressure, and also challenges are often lack of knowledge based on what are the available solutions, how can we create a balanced and integrated design. Often current standard equipment is not sufficient to address the volatile organic compound or dust, and some targets are hard to meet. Besides specific emission control, it's also often a challenge to create a link to related challenges, and if you can create a successful link, the business case gets much more positive. Let me give you some examples. Can we improve emission control outside together with the improved working environment for your operators? Can we combine an upgrade in explosion safety? Can we recover energy while addressing emissions? And can we improve processes? Can we reduce waste? Now currently the prices of raw materials are increasing, so can we reduce waste concerning that raw materials? Some examples on how to create a holistic approach while addressing emission control. How to handle these? Well, first, let me discuss the approach. In our opinion, the best approach is always data-driven. Do you have measurements available? If not, which measurements need to be done? Where and how? Second step is, can we validate those and can we model so that we can predict future outcome? High level scene, we always address 3 steps in our solution approach. First, it's best to eliminate the sources. How can we prevent emissions? That's always the biggest win. If we're not able to prevent emissions, can we extract them as best as we can and the most effectively? Can we create a perfect extraction close to the source extraction? And last but not least, in the third step, if we have done so and created the optimum, particles are getting smaller, getting more expensive to create the perfect extraction. That's a thin balance. Then we start diluting, putting some extra waste stream or air to dilute the concentrations. Those 3 steps approach are always central in addressing emissions. Let me walk you through our approach, how we address them. As start, we will always strive from data, so measurement is key. Then we will model, air technical model the data to predict future outcomes. We have developed our own technical model for over 2 decades. Also incorporate a lot of industry knowledge in that modeling. And then third, based on that modeling, we will start engineering and then building the solutions. So when we have done the modeling and the pre-engineering, we look into, okay, how can we apply that in a technical solution? And let me walk you through the steps. It will be high level. If you want to know, if you want to know more about a specific technical solution, please reach out, book a meeting. We can look specifically to your setup. But this is just a high level walkthrough of what kind of solutions are out there. So in order to develop the right technical solution, it's crucial to first understand the particle in detail. Particles can be dust, vapor, aerosols, or odor. So what are the specific characteristics? Are explosion characteristics specifically? What's the density? What's the particle size distribution? And so on. All how to predict the behavior of that specific particle or volatile organic compound. Then how to address that particle close to the source that comes with specific hood design. How to capture them effectively. Do we create the right piping layout? What kind of characteristics need the piping to be? And last but not least, how to filter, how to extract the particle. And we have several examples. We have several dust extraction solutions, from backhouse filters to pocket filters and so on. But that very much depends on the setup on your side, type of particles, and what kind of target do we want to meet from an emission control standpoint. We can use pre-separation systems like cyclones to address the particles. We have belt filters, both dry and wet. We have active carbon solutions based on often on vapors and odors, often in combination with other filtration solutions, for example, to make sure the dust doesn't enter the active carbon, because it decreases the lifetime of the carbon. The same with condensation. The carbon doesn't like water, so how do we prevent that? Thermal oxidizers you can incorporate in your end of pipe solution. We have acoustics from a technology where we're able to address the finer particles in the particle size distribution that will be effective between 0.3 and 3 microns in order to agglomerate the particles to capture them effectively. That can always be combined in the setup. And last but not least, scrubbing, how to, let's say, address the dust or the vapors with a scrubber. These are, again, examples of technologies which are used often in combination to perform an effective emission control. As I mentioned before, we advise you to have a holistic view on emission control and other related, let's say, angles on particles, because there's often some success to be found. So I'll give you an example on how we apply technology on the holistic view in the combination of emission control and, in this case, energy recovery. We have developed an energy recovery scrubber Overall, it's very effective. It uses the least amount of water. Or solvent. We will always look into the right liquid to gas ratio, and also, as I mentioned, how can we recover energy? It focused not only on this sensible heat, but especially with scrubbing, you can also focus and recover energy from the latent heat. And there's a lot of energy stored in there. While you recover the energy, and of course, the scrubbing needs to do the most important thing. That's address your emission control. That's the topic of today. Then how can we combine it and bring it to the consumer on your side? Because now I'm talking about the producer of the energy. Here you see a setup we apply often in practice, for example, with a heat pump, that we upgrade the heat to the right consumer range. This is just an example how to combine emission control with energy recovery. As I mentioned in the beginning, let me walk you through some case studies we've done both in fast-moving consumer goods, food, and also in the chemical industry. The first example is that we address emissions, specifically VOC, but also odor, together with energy recovery, as I discussed, based on the energy recovery scrubber. The potential is huge, especially in the latent heat area, where we can address the temperature, bring it further down at the dew point, and release a lot of energy there. Here you see the reduction both from a kilowatts point of view, but also CO2 point of view. This was done in the food industry. Another example would be in the chemical industry, where in the current setup, a thermal oxidizer was already there, increased gas bill, it uses a lot of gas, and also the license to operate was in play. We have advised upon, measured thoroughly, and then decided in the 3 steps approach to really put the emphasis on the source elimination. Can we improve the process? Can we recover a lot of vapors back into the process to optimize the process result, but also reduce emissions? We modeled, and it could be done to stay well within the limits. So in the end, even though the thermal oxidizer could be, let's say, out of play, that lowered the gas bill, but also increased productivity because we recovered a lot of, let's say, waste formerly. So this is an example on how to combine process improvement, energy recovery or energy reduction, and emission control. The last example I want to share with you today is based on the tobacco industry in North America. Odor emissions was the central key. We have combined it with energy, but I want to share, let's say, the setup for a scrubber, but also cold plasma technology, while we're able to reduce the odor almost to 90%. This is just an example on how to use technology and reduce emissions. So I hope I gave you a great overview on emission control and how to use it in combination with other industrial challenges to create potentially a good business case, but also gave you an idea of the technical solutions and availabilities out there, how to address your specific problem. So if you have any further questions or like to spar about your specific setup, please reach out, book a meeting, send an email, and we'll be happy to speak to you. And wish you a great day. Thank you. Bye-bye.